The false vacuum hypothesis is a fascinating but highly speculative concept in theoretical physics and cosmology. Imagine the universe as a field of energy, with different states it can be in. Much like water in different phases: solid ice, liquid water, and vapor. In this analogy, our universe's current state is like ice, representing a false vacuum. However, there's a deeper, lower energy state, like liquid water, called the true vacuum. The hypothesis suggests that our universe might not be in its most stable state, the true vacuum, but rather in a metastable state, the false vacuum. Physics states that there are two types of vacuum: true vacuum, the most stable, lowest energy state; false vacuum, not exactly stable, but not exactly decaying either. Think of a ball on a hill and imagine it rolling down, represents decaying. It rolls right down to the bottom and sits there. It is fully stable. That's a true vacuum. Now think of the same ball again and imagine rolled down again. This time it doesn't reach the bottom, but gets stuck in a ditch halfway down the hill. This is a false vacuum. It's not stable, at the bottom of the hill, but it's not decaying either, rolling down. This is metastable. Now think of that concept but in the real world instead. If our universe was in a false vacuum state, a high enough energy event could possibly cause it to decay, cause the ball to tumble down from the ditch, and move into a true vacuum state. The true vacuum would initially be a bubble and expand outwards at the speed of light. That would be very lethal and would incinerate us. It is very, very unlikely for us to be in a false vacuum state, as nothing has happened over the past 14 billion years. Inflation was probably not high enough in energy to push us into a true vacuum state, push the ball out of the ditch, or inflation did not happen at all. Or the universe could be in a very stable state. For us to be sure though, we need a better understanding of a multiverse, and we don't have that just yet. Our universe could be in a metastable state, and the transition from a false to true vacuum could happen at any time. But no need to worry. Our universe is too young to be pushed into a true vacuum state. Now, if the universe were to tunnel or transition from the false vacuum to the true vacuum, it would have some profound consequences. Change in laws of physics, the fundamental constants of the universe, like the speed of light or the strength of forces, could change. This would lead to entirely different physical laws, altering the behavior of particles and matter. The laws of physics are governed by fundamental constants, such as the speed of light, c, the gravitational constant, g, the Planck constant, h, and the strengths of the fundamental forces like electromagnetism and gravity. If the universe were to transition from the false vacuum to the true vacuum, it could result in a change in the vacuum expectation value of certain fields. This change could propagate throughout the universe, leading to alterations in the values of fundamental constants. Imagine a universe where the speed of light is different, or where gravitational attraction behaves differently. These changes would have far-reaching consequences, affecting everything from the behavior of matter and energy to the stability of atoms and the formation of celestial structures. New particles and fields. This transition could create new particles and fields that we've never observed before, potentially leading to entirely new forms of matter and interactions. During a vacuum phase transition, new fields and particles could emerge. These could be entirely novel entities that don't exist in the current universe. These new particles might interact differently with matter and other particles, potentially leading to new forces or phenomena that we cannot currently predict or observe. The appearance of new particles could have implications for particle physics experiments, and could open up new avenues for scientific exploration. Cosmic catastrophe. Depending on how this transition occurs, it could be catastrophic on a cosmic scale. The structures and matter we know might be disrupted or destroyed, completely reshaping the universe. The transition from a false vacuum to a true vacuum would involve a rearrangement of the vacuum state, which could be catastrophic on a cosmic scale. Depending on the energy scale of the transition, it could lead to the destruction of existing cosmic structures, including galaxies, stars, planets, and potentially even the disintegration of all matter. It's worth noting that the specific consequences of such a catastrophe would depend on the details of the vacuum transition and the energy involved, how the universe could end in a false vacuum decay. This is the way the world could end, not with a bang, but with a quantum vacuum decay of the ground state of the universe to its true minimum. The universe underwent radical phase transitions in the past. These transitions eventually led to the division of the four fundamental forces of nature and the panoply of particles we know today. All of that occurred when the universe was less than a second old, and it has been stable ever since. But it might not last forever. To understand the stability of the universe, first we need to talk about phase transitions. Phase transitions are when a substance undergoes a rapid, radical transformation. They happen all the time. You boil water, and it transforms from a liquid into a gas. You cool that same water, and it turns into a block of ice. Perhaps the most exotic phase transitions are those that happen to quantum fields. Quantum fields are the fundamental building blocks of the universe. That field soaks all of space and time like bread dipped in olive oil. The way those fields interact and communicate with each other makes up the forces and physics of our existence. That existence is based on four fundamental forces: gravity, the weak force, electromagnetism, and the strong force. But it hasn't always been this way. In the earliest moments of the cosmos, those forces were united. As the universe expanded and cooled, the quantum fields underwent phase transitions, splitting apart one by one. The last phase transition occurred when the electromagnetic force split from the weak force. That splitting gave rise to the photon and the W and Z bosons, the carriers of those two forces. Since that event, which happened when the universe wasn't even a second old, everything's been stable. No more splitting, no more phase transitions. The four forces of nature went on to shape and sculpt the evolution of the cosmos for billions of years. As far as everything looks, it's all stable for now, anyway. The stability of the universe is tricky to measure. Sure, it's been over 13 billion years since anything as interesting as a phase transition has occurred. Yes, 13 billion years is a really long time, but in the world of quantum fields, anything can happen. However, it's crucial to emphasize that the false vacuum hypothesis is highly speculative and theoretical. There's no empirical evidence supporting it, and it's still a topic of debate among physicists. But it's a captivating idea that showcases the complexity and mystery of the universe's fundamental nature. Scientists continue to explore these concepts through mathematical models and theoretical physics, searching for clues that could help us understand the true nature of the cosmos. That's all for this video. I hope you enjoyed it. Let us know your thoughts in the comments section below. If you haven't already, then don't forget to subscribe and press that like button. Also, hit the bell icon, so you can never miss new updates from us. Thank you for watching, and we will meet you in the next one.